Actually, let me do the simple, not the simple, but the pure integration first. So this is Calculus 2 problem session, 5th day, 2nd session. So in section 8.1, number 39, we have the integral of 1 plus sine x over cosine x dx. Well, any suggestions? What can we do?
Separate it.
Yeah, that's what I did.
In what way? What do you mean by separate?
1 over cosine x plus sine x over cosine x.
Okay. So 1 over cosine x dx plus sine x over cosine x dx. So this is the integral of the secant plus the integral of the tangent. And both of these we've done. Actually, the simplest thing is not even to change this. Here, to make a substitution, u equals cosine x, and what you would get is minus the natural log of the cosine, because when you differentiate this, you get 1 over the cosine times minus the sine, which cancels that. And the integral of the secant is something that you can just find in the text or work out. You basically, I think the trick is you multiply secant by secant plus tangent over secant plus tangent, and this is a known integral. So so this I assume you don't need help with, because that's in the text. That's all you have to do. Right.
So it would be ln absolute value secant x plus tan x, and then we have exactly. Okay, because when I looked up the problem, I got a different answer than that. But I think it's probably because they just simplified it a different way, or like they did something.
Well, there are lots of ways to write trigonometric functions. I mean, there are all sorts of identities that prove that different trig expressions are the same. So, but basically it's the log of the secant plus the tangent. That's what it is.
All right, thanks, Professor.
Could it also have been ln of cosine x?
Sorry, ln of what?
Ln cosine x.
Here?
When you separated the equation.
No, this is not the log of the cosine. Because if you differentiate the log of the cosine, you in fact get minus the tangent.
Okay, I see.
So the integral of 1 over the cosine of x is not the log of the cosine. Because when you differentiate log over cosine, you get 1 over cosine times the derivative of the cosine, which is minus the sine. Are there other questions about that?
No, I don't have any further questions about this one.
So section 7.3, number 45. So this is the section on the shell method. It says a solid is generated by revolving the region bounded by y equals a half x squared and y equal 2 about the x-axis. So this is the horizontal line, y equal 2. If you take the parabola y equal 1/2 x squared, that looks like this. So the region bounded by, oops, let me draw a better picture. I'll actually go to another piece of paper. This is section 7.3, number 45. -2, -1, 0, 1, 2. And this is the horizontal line, y equals 2. And the parabola, y equals 1/2 x squared, looks like that. So the region bounded by y equal 1/2 x squared and y equal 2 is this parabolic region. And you generate a solid by revolving this region around the y-axis. A hole centered along the axis of revolution. So we're going to drill a hole in this. And we want to drill the hole so that this part, which we're going to cut out, is 1/4 of the volume, of the total volume. And how big does the hole have to be? Right? So that's the question. So let's see, what is the volume of the original solid that you sweep out? If we're going to subtract 1/4 of the volume, we have to know that. So how can we set up something to find out the volume of what we get when we rotate this around the y-axis? You can use the disk method or the shell method, perhaps. What should we use?
Yeah, Professor?
Yes.
Hello? Yeah, Professor, regarding this graphing things, like sometimes I'm able to do it, but sometimes I'm having like a little bit confusion regarding the graphs, just when you try to graph.
I'm sorry, it's hard for me to hear. Can you sort of speak more
Okay,
loudly
yeah.
and directly into your microphone?
Okay, so I'm saying that I'm having trouble graphing sometimes. This is what you're just doing. I'm able to do it before, but like somehow every time when I do it and I check my answer, somehow I always get a little bit confused.
I'm sorry, somehow you always get what?
Somehow I always get like one mistake or something like that.
Oh, you say you always get one mistake.
Yeah.
Well, okay. So that's not a question, that's more a statement.
Yes, actually, I apologize because I'm in the train station, so it's a little bit loud.
So here, when I drew the picture, I say, this is the parabola. This is the horizontal line.
Okay.
This is the region it cuts out. Now, what's a little bit tricky is, in fact, you don't need this whole picture because really, if you just look at this, not from -2 to 2, from 0 to 2, what you get when you rotate this around the y-axis is exactly what you get when you rotate this around the y-axis. It's going to sweep out the same solid.
So you can do it. Yeah, actually, you can do it. Yeah.
So
okay.
You can look at both pictures, but I mean, the mathematics that you write down will be exactly the same. So what is the volume? So if we're going to use the shell method, the volume, we're going to take the shell swept out by I'm going to take a piece like this, sweep it around, that sweeps out a shell. And the shell method says this is going to be pi times the integral, 2 pi times the integral from 0 to 2 of, the formula is P of y, H of y, dy. And P of y is the distance to the axis, and H of y is the height. So if you take an x, if you take how do I want to say this? So this height is, this is 2. This is a half x squared. So this height is 2 minus a half x squared. Actually, I'm sorry. So 2 minus a half x squared. No, let me. So I'm going from 0 to 2, but I'm integrating with respect to x. And at any point x, the height of this shell is 2 minus a half x squared. And the distance to the axis is x. So the volume we want is 2 pi integral from 0 to 2, 2 minus 1/2 x squared x dx. That's 2 pi integral from 0 to 2, 2x minus 1/2 x cubed dx, which is 2 pi x squared minus 1/4 x to the 4th times a half from 0 to 2. This is 2 pi 4 minus 2 to the 4th is 16 over 8, which is 2. So this is 2 pi times 2, or 4 pi. So if I did this calculation correctly, the volume of this entire object is 4 pi. So let me just double check the work and make it clear. So the volume is an integral with respect to x. X goes from 0 to 2. For any x, this vertical slice through the body has height 2 minus a half x squared. And the distance to the axis is x. So we're integrating 2x minus a half x cubed times 2 pi. That's x squared minus x to the 4th over 8. So we get 4 minus 2. 4 minus 2 is 2, times 2 pi is 4 pi. So the first step is to find out what is the total volume. and it seems to be 4 pi. Okay. Is there a question about that? Now, suppose we drill a hole through this body. So the hole is this area I've indicated in red, and we're going to cut out the hole we get by going from 0 to some number, I'll just call it r for the radius. So from 0 to r, we're going to sweep this region out. Let me draw a picture of that. So if I just want to look at the right side, this is 0, 2, 2. This is y equals 2. This is y equals a half x squared. But we're only going to go up to some number r. So the region we're sweeping out is this region. And the volume of that, this is 2 pi, the integral from 0 to r, exactly what we had before. The height of this cut for any x is 2 minus a half x squared times the distance to the origin dx. So that's 2 pi, the integral from 0 to r, of 2x minus x cubed over 2 dx. That's exactly what we got before. 2 pi, the integral of x squared minus x to the 4th over 8 from 0 to r. So that's 2 pi r squared minus r to the 4th over 8. And we want this to be a quarter of the total volume. So we want, so this is the area of, this is the volume of the hole. And we want to have the hole fill up, take out a quarter of the volume. Now the total volume is 4 pi. And we want a fourth of that, which is pi. So we want to find r such that this is equal to pi. So we need to solve the equation. The pi's cancel. 2 r squared minus r to the 4th over 4 equals 1. So it looks like if we can solve this equation for r, we have the answer. Okay. Does this make, are there any questions about this? I mean, there's a certain amount of sort of pure thinking that goes into this.
Quick question.
Yeah.
So when you started finding this volume, what do you, I think I'm just confused, like what are you finding now? Like what will this volume give you?
Okay, so let's go back to the problem. A solid is generated by revolving the region bounded by y equal a half x squared and y equal 2 about the y-axis. So this is the region, this parabolic region, and we rotated that around the y-axis, and this was the region. And when we calculated the volume, we got 4 pi. But now we want to drill a hole in the center of that three-dimensional object and cut it out. We want to remove a quarter of the total volume. So the whole volume is 4 pi. We want to cut out a hole that has volume pi. Okay? That's what it means to remove a quarter of the volume. So the question is, if you take a hole of radius r, what is the volume of this? And as a function of r, if I did this arithmetic correctly, it's equal to 2 pi r squared minus r to the 4th over 8. Now, so I need to solve this equation. Let me rewrite this slightly. This is r to the 4th over 4 minus 2r squared plus 1 equals 0. Or if I multiply by 4, r to the 4th minus 8r squared plus 4 equals 0. Just to make this a little bit easier, if I let s equal r squared, if I make that substitution, this becomes s squared minus 8s plus 4 equals 0. This is a quadratic equation. I can solve a quadratic equation. S is equal to minus b plus or minus the square root of b squared minus 4ac. 4 times 4 is 16 over 2. This is 8 plus or minus the square root of 48 over 2. That's 4 plus or minus, if I take out a 4, I get plus or minus the square root of 12, which is 3 times the square root of 4, which is 2 times the square root of 3. If I want it to be positive, 2 times the square root of 3. That's what s is, which is what r squared is. So the radius of the hole is the square root of 4. Let's see, it goes plus or minus 2 root 3. No, it has to be minus. Otherwise, it's too big. So 4 minus 2 root 3, that's the radius of the hole. And so the diameter of the hole is 2 times the radius, 2 times the square root of 4 minus 2 root 3. So that's the solution of the problem. So we had to calculate 2 volumes, the total volume and the volume of the hole. Okay. Let's see. Does anyone else have a question? I can try number 47 if you like.
Yes, please.
So this is section 7.3, number 47, for the volume of a torus. Okay, so a torus is just another name for a donut. So if you remember what a donut looks like, that's what a torus is. You take a circle and you rotate it around an axis, and it sweeps out a torus. So the torus is formed by revolving the unit circle. So this is the circle. X squared plus y squared equals 1. That's the circle around the center at the origin, whose radius is 1. And we take the vertical line x equal 2, and when we revolve this around, we get a torus. Find the volume of this donut-shaped solid. Okay. Well, the axis is x equal 2. And if we take, so we're going to use the shell method to compute volume of the torus. So here we have the axis, and here we have a vertical slice through the circle, and what is this length? So if the circle is given by the equation x squared plus y squared equals 1, y squared is 1 minus x squared, so y is plus or minus the square root of 1 minus x squared. So the vertical line through the point x, the line x, in this circle, from the top to the bottom is h of x is 2 times the square root of 1 minus x squared. From minus square root of 1 minus x squared to plus the square root of 1 minus x squared. That distance h of x, that height is 2 times the square root of 1 minus x squared. And the distance from x to the axis of rotation, p of x, is 2 minus x. So if we use the formula for the volume, it's 2 pi, the integral from minus 1 to plus 1 of, it's p of x, h of x, dx. P of x is 2 minus x times the square root of the times, so 2 minus x and times 2 times the square root of 1 minus x squared dx. So that's, take this 2 out, this is 4 pi, the integral from minus 1 to 1 of 2 minus x square root of 1 minus x squared dx. So this looks like a somewhat complicated integral, but maybe it's not too complicated. This is, let me write this as 2 integrals. 4 pi times 2 times the integral from minus 1 to 1 of the square root of 1 minus x squared dx minus the integral from minus 1 to 1 x times the square root of 1 minus x squared dx. Now, the integral from minus 1 to 1 of the square root of 1 minus x squared dx, that's just the area of the unit circle. And 2 times that, sorry, of the unit semicircle, 2 times that is the area of the whole circle. Circle of radius 1 has area pi. So this integral, this is just equal to pi. It's just the area of a circle of radius 1. Here, we make a substitution, u equal 1 minus x squared, and we can do the integral. That's just a straightforward substitution. So I can do it if you like, but that should not be extremely difficult. Actually, we can make it a little bit easier. So this first part is 4 pi squared. This function, if you replace x by minus x, it changes sign. This function is going to turn out to have, this integral will turn out to be 0. So the answer is just 4 pi squared. And that's what it is. Other questions? Okay. If not, I have to take a break a little bit early today, so we'll stop now. And again, I'll be back at 10 o'clock tomorrow morning. Okay, see everyone tomorrow. Bye.
Thank you.